So before we do our lesson, I would like you to try this warm up. Please pause the video and give it a try. So I'm hoping these problems were review. We're actually using the Pythagorean theorem for both of them. For number 1, we are going to get 6 squared plus 8 squared equals c squared. You can actually use any variable you want. When you calculate it out, you will get that c, our missing side, is equal to 10. For number 2, we are going to do 3 squared plus b squared, again you can use any variable you'd like, is equal to 10 squared. If you simplify everything out, you will end up getting that b is 91, or sorry, b squared is 91, and b is the square root of 91. So I have listed here the distance formula and the midpoint formula. I imagine you've probably seen these at some point before, but just in case, here they are. By the way, in case you were wondering, the midpoint formula, these little things right here are 2's. I just had some stylish issues when I was writing them. So you can write those out in your notes. I do recommend that you just have them on hand, and then we're going to just do some examples. So for these examples, please go ahead and pause, and I want you to find the distance and midpoint. So for number 1, to find the distance, we are going to use the distance formula. And we are going to get 5 minus negative 8, and that's going to be squared, plus negative 3 minus 3, also going to be squared. That gives me 13 squared, plus 6 squared. By the way, you'll notice I actually took out the negative sign. So it's not 100% correctly written, but the negative sign is going to go away anyway. So my final answer is the square root of 205. Then for the midpoint formula, so the midpoint is just going to be negative 8 plus 5 over 2, comma 3 minus 3 over 2. Which is going to give me negative 3/2, comma 0. So for number 2, I gave you something that had a variable in it, just because it's extra fun. So distance formula, pretty much the same idea. You can use the same formula. The only difference is that I do have the letter A in there. So I end up getting the square root of 4 squared plus 2a squared. Be careful, make sure that you get that 2 in there. In the end, this ends up being the square root of 16 plus 4a. Be really careful on this problem. You cannot... Sorry, 4a squared. You cannot actually take the square root of that, so we're going to leave it in radical form. For the midpoint of this one, I end up getting 0 minus 4 over 2, comma a minus negative a over 2. Sorry, a plus negative a over 2. That's going to give me negative 2, 0. So next thing that also should be reviewed are the x-intercept and the y-intercept. So the x-intercept is the point at which the graph crosses the x-axis. Keep in mind the x-axis is the horizontal one. Y-intercept is the point at which the graph crosses the y-axis, which is the vertical axis. You also can find the x-intercept by looking to see when y equals 0, and you find the y-intercept by looking to see when x equals 0. So go ahead, pause the video, and label the x and y intercepts on this graph down below. So hopefully you figured out that these 3 right here are all our x-intercepts. And we'll do this one in a different color. This one right here is our y-intercept. So for this one, I would like you to label the intercepts, write them as a coordinate. Go ahead, feel free to pause the video. I am going to tell you that a few of these are going to be decimals, so don't round them. So for a few of these, I just had to estimate. Negative 3, 0. If you tried to add an extra intercept at negative 2.7 or so, that's fine, because I think my graph wasn't perfect. So all of these ones I'm going to circle in green are my x-intercepts. However you label them, by the way, is fine. If you just did it on the side, that's okay. And these two, 0, 3, and about 0, 1.5, these are my y-intercepts. I do want you to note this graph looks really weird. It's actually not a function because there are multiple y values that go with some of the x's. But generally in real life you don't see graphs like this, but you might occasionally see something like this in class. So for the next example, we are going to find the intercepts and graph. There are actually a few ways to do this problem. Let's start with finding the intercepts. So remember, to find your x-intercept, you are going to have to set y equal to 0. And when you do that, you get 0 equals x squared minus 4. If you solve this out, you get x equals plus or minus the square root of 4, which gives you plus or minus 2. So I have x-intercepts at 2, 0 and negative 2, 0. By the way, please make sure that you write your x-intercepts as a point. Same thing with the y-intercepts. So y-intercept, I am only going to have one. Actually, if you have any function, you should only have one y-intercept. Something that's not a function, like the thing above, will have multiple y-intercepts. And actually, I just looked at the thing above. Some of you might have caught this, and I just realized I missed a y-intercept. Oops. So there is a y-intercept at 0, negative 0.8. Sorry about that. If you got that. Generally, if I make a mistake like that in class, I give a sticker to anybody that gets it right. Unfortunately, we're not in class right now. So back to this bottom example. To find my y-intercept, I am going to set x equal to 0. And so I get y equals 0 squared minus 4, which gives me y equals negative 4. So there is a y-intercept at 0, negative 4. So now I'm going to graph that. And when you graph these, there are several ways to do it. So in this section of your book, they actually are just kind of assuming you're going to plot points. Some of you might recognize that this, if you remember doing function transformations in Algebra 2, you might recognize that this is a parabola with a vertex at 0, negative 4. And actually, having the intercepts helps out with that. I do recommend that if you're drawing a parabola, we already do have 3 nice points. We have our 3 intercepts. So we actually know a few things. I usually try to find a few negatives, a few positives, and 0 x value, put those x values in, and then find the y. We already got these 3 right here. Those are our intercepts that we just got. So now if you just substitute in 1 and negative 1 for both of those, you will get negative 3. That'll just help you draw a better graph. And this does end up becoming a nice parabola. With parabolas, try not to make them pointy looking. Try to make them nice and curved. Mine is definitely far from perfect. Whenever I draw it, this type of thing on the iPad, it doesn't look perfect. But do the best that you can to make them look like a nice curve.